Welcome back. Functional Analysis FAV 008 by Professor Dr. A.G. Srinivasan. Let's start with some well-known inequalities. Number 1, modulus A plus B is less than or equal to mod A plus mod B. Modulus A minus B is less than or equal to mod A plus mod B. If P is greater than 1 and 1 by P plus 1 by Q is equal to 1, Holder's inequality states that sigma I is equal to 1 to infinity, modulus AI BI is less than or equal to sigma K is equal to 1 to infinity AK power P power 1 by P plus sigma M equal to 1 to infinity BM power Q by 1 by Q. When P is equal to Q is equal to 2 in this Holder's inequality, you will get sigma I is equal to 1 to infinity AI BI with the modulus is less than or equal to sigma K is equal to 1 to infinity AK square. Because P is 2, this becomes square root. Similarly, into sigma M is equal to 1 to infinity BM modulus square. And this inequality is called Cauchy-Schwarz inequality. The third inequality, fifth inequality is the Minkowski's inequality. Sigma I is equal to 1 to infinity AI plus BI the whole power P whole power 1 by P is less than or equal to sigma K is equal to 1 to infinity AK power P whole power 1 by P plus sigma M is equal to 1 to infinity BM power P whole power 1 by P. We are not going to prove any of these inequalities because these are available in almost every textbooks, and you can also find in search engines, in internet, the proof of all these inequalities. So I am not going to prove it. We also had some time back another some more inequalities. For example, the triangle inequality metric space. If xd is a metric space, then d of xy less than or equal to d of xz plus d of zx for all x, y, z belongs to x. And if x1, x2, etc. xn belongs to x, d of x1, xn less than or equal to d of x1, x2 plus d of x2, x3, etc. d of xn minus 1, xn called generalized triangle inequality. We proved all this in the previous lectures. We also proved that for every x, y, z w belongs to x, modulus d of xy minus d of zw is less than or equal to d of xz plus d of yw. D of modulus d of xz minus d of yz is less than or equal to d of xy. These two also we proved in the previous videos. We also review some simple results from lower mathematics. A real valued function f is said to be an increasing function if for all xy with x less than or equal to y, we have f of x less than or equal to f of y. If for every x and y with x less than or equal to y, fx is strictly less than f of y, it's called strictly increasing function. This is increasing function and this is strictly increasing function. In the same way, f is a decreasing function if f of y less than or equal to f of x for every x less than or equal to y, and is strictly decreasing if x less than or equal to y should imply f of y less than f of x. F is said to be monotone if it is either increasing or decreasing. And one more result, a function which is differentiable is monotone or increasing or monotone decreasing based on f dash. If f dash is positive, it is monotone increasing. F dash negative, it is monotone decreasing. This is Dr. A.G. Srinivasan. We will see in the next video some more examples of metric space. Thank you.